Kia ora, here are parts A, B and C of question 3 from the 2015 Complex Numbers paper. So question 1, we've got Z is equal to 4 plus 2i, and we've got another complex number W, and that's negative 1 plus 3i. We're asked to find the arg of ZW. Right, remember what the arg is. So the arg of x, not that we're usually going to call a complex number x, that's confusing, let's call it z. If we're just looking for the arg of z, and that's z there, the arg means the angle formed by those two lines. I'm being very loose here. So the first thing we're going to do is figure out what is ZW. So ZW is equal to 4 plus 2i times negative 1 plus 3i. Right, that equals negative 4 minus 2i plus 12i, so that's going to be plus 10i, and then 6i cubed, so it's going to be minus 6. That gives me ZW equals negative 10 plus 10i. Right, the easiest way to do this is just to have a wee look. So negative 10 back here, plus 10i up here. Whoosh, there we go. So you can see from looking that the angle there, WZ or ZW, is equal to 3 pi on 4. Right, if you wanted to figure that out with a bit of trig, you could draw your right angle triangle in there. You've got 10 here and 10 here, right angle there. Work out what theta is. It's going to be tan inverse of 1. Right, opposite over adjacent. But we don't want that angle, we want its supplement, right, which is that angle around there. So arg of WZ is equal to 3 pi on 4. Okay, on to part 2. Right, for what real values of k does this equation here, oops, let's just make it a bit bigger, there we go, have real roots? So for an equation to have, not to have real roots, to have equal roots. So for equal roots, we require the discriminant to be 0. So b squared minus 4ac equals 0, a equals k, b equals 1 over k, and c equals 2. So we're going to look at b squared is 1 over k squared minus 4 times those numbers gives me 8k equals 0. In other words, 1 over k squared equals 8k. Just scoot up to here to finish this off. Right, not going to take long. 1/8 is equal to k cubed, so k is equal to 1/2. Right, only one solution to that. So that's my answer there. So that's just another little achieved question. Okay, this equation is, we're told that one solution of this equation here is w equals negative 2. So as soon as we see that, we should be thinking factor theorem. If a is a real number, find the value of a and the other two solutions of the equation. Okay, so by factor theorem, we know that p of negative 2 equals 0, where p of w is equal to this, 3w cubed plus aw squared minus 3w plus 10. So the first thing we're going to do is substitute in negative 2. So p of negative 2 is equal to negative 24 plus 4a plus 6 plus 10. And we know that that all equals 0. So that tells me that, let's have a look, negative 8 plus 4a equals 0. So a equals 2, right? Just check that when you do it, if you do it quickly, because if we muck this up, the whole thing's going to go wrong. So that's a U code to get to there. What we're going to do now is pop that back into our equation. And we've got 3w cubed plus 2w squared minus 3w plus 10 equals 0. So we want to factorize that. I'm going to do this two different ways. The first way I'm going to do it here is by matching up the coefficients, right? Which, when you've done enough of these, is probably I'd say the best way to do it. We know that w plus 2 is a factor. So let's first take a look at what we've got to match up. We're going to have a quadratic come out in here, to work with a bit more. So we must be getting a 3w cubed, so that means the first term here has to be 3w squared. Right, now we must be ending up with a plus 10, and that's going to come from plus 2 times something else, so that's going to be plus 5 here. All we've got left to do is to match up either the plus 2w squared or the minus 3w. So I'm going to do how will I get the squared term, but it will work obviously either way. So if we go and expand this out, what we've got so far is we've got 6w squared coming in, but we only want 2 of them. So we need to have a takeaway 4, because the other term will come from w times minus 4w. Right, so if you found that a bit strange, let's now have a look at when we expand, what are we going to get? I'll just change colours for that with green. We can see that when we go w times 3w squared, that'll give me my only cubic term, 3w cubed, so that's right. When I go, I nearly need another colour pen again, there's 2 times this one, that gives me my 6w squared, and then this times this takes away 4 of them, so that's that one. Okay, so now I'm just going to check the linear term, because we didn't work that out directly, and I just have to change colour, so I'm going to use a funny purple. So the linear term, we want to end up with minus 3w. I'm going to get minus 8w from those two purple ones together, but then I'm going to magically be adding back 5w, so it all works out. Right, so that's the first way to do that. Now what we've got to do now, first thing we've got to do is rewrite this hideous mess. And then we're going to factorize that quadratic, and that's going to give me my other 2 solutions, and you should be able to guess that they might turn out to be complex. If they are complex, they're going to come in a matching pair where one is the conjugate of the other. So that's what I'm going to do now. I'll just put a new slide in. Right, so the last thing we've got to do is to factorize this. 3w squared minus 4w plus 5 equals 0. Now I look at that, and completing the square on that is going to be ugly because I've got a 3 here. If I divide through by the 3, I'll get this, and that's still going to be awful. So I'm just going to go straight to the quadratic formula. Most of you have probably already done it by now. So w equals, so a is 3, b is negative 4, and c is 5. So w will be 4 plus or minus the square root of 16 minus 60 divided by 6. So that works out to be 2/3 plus or minus the square root of negative 44 on 6, which is 2/3 plus or minus 2 on 6 times, well, the negative 11 is 11i squared. So my final answer is 2/3 plus or minus the square root of 11i divided by 3. So that's it. So that's a nice merit question. The other way that you could have got this quadratic coming out, if you don't like matching the coefficients, is by doing long division. I haven't done that in here because this video is long enough, but you can ask me about that in class if you need to. Thanks for watching.